Hello and welcome. In this video, we'll be talking about TensorFlow 2.x and eager execution. This course was originally created in the days of TensorFlow 1.x, but now has been updated for TensorFlow version 2.x, which includes a major update and some important new capabilities. One of the major changes within TensorFlow 2.x is that the Keras framework has become the official high-level API for TensorFlow. Keras is a deep learning API written in Python and is known for its user-friendliness. It offers abstractions that make it easy to develop deep learning models. However, Keras does not have its own execution engine and is dependent on other frameworks like Theano or TensorFlow. With TensorFlow 2.x, TensorFlow has not only become the default execution engine for Keras, but they are also now more tightly integrated. What this means for TensorFlow users, especially Python developers, is that they can now develop models more easily using Keras interfaces, yet leverage the powerful capabilities of TensorFlow in the back end. Another TensorFlow 2.x enhancement is performance optimizations, multi-GPU support, and improved APIs for better usability for GPU acceleration. Besides this, one very prominent change in TensorFlow 2.x is eager execution. In cases where Keras, which is a high-level API, isn't sufficient for your needs, you'll still need to use the TensorFlow low-level API. In such cases, eager execution mode is activated by default in TensorFlow 2.x, and, in fact, is the recommended way of using the TensorFlow low-level API. Please keep in mind, however, that the low-level TensorFlow API involves the use of linear algebra to express neural network layers. So, what is eager execution mode? Well, let's have a look at this code snippet. As you can see, we are initializing two tensors, A and B. Then we compute the tensor.product and assign the result to C. But so far, no computation has happened. C only represents an execution graph which does not yet have a value. Only once executed within a TensorFlow session does a computation happen, and a value is assigned to C. As such, this makes TensorFlow code very hard to debug, as intermediate results are not accessible. This is where eager execution kicks in. With eager execution enabled, which by the way is the default in TensorFlow 2.x, code gets immediately executed, line by line, and intermediate results are instantly available. Eager execution makes TensorFlow code look like ordinary Python code, and this is achieved without even needing to change your code when jumping between the two TensorFlow versions. Let's see how. The trick is in the data type. In TensorFlow 1.x, each tensor is a type of TensorFlow.python.framework.ops.tensor. With eager execution enabled, the type changes to eager tensor. While having programmatically similar behavior, eager tensors have additional functionality. This way, intermediate results can be obtained at any time. This concludes the lesson on TensorFlow 2.x and eager execution. Thanks for watching.